6.3 Pascal's Triangle and Binomial Theorem by Meenakshi Gadel. Learning goals for this chapter: to be able to construct Pascal's triangle, to be able to identify the terms in Pascal's triangle, to be able to understand and use Pascal's triangle for binomial expansion. How to construct Pascal's triangle. Start with the first two rows, which are 1 and 1, 1. To find the numbers in the following row, add the two numbers directly above it. In this case, the number will be 2. Where there is only one number above, which is at the end and beginning of each row, place a 1. Repeat these steps for all of the following numbers and rows, and now you are able to create Pascal's triangle. Identifying the terms in Pascal's triangle. In Pascal's triangle, a term or a single number can be portrayed as t and n, r as a subscript. N represents the horizontal row number, r represents the diagonal row number. The first horizontal row is row 0. The first diagonal row is also row 0. This is how the following horizontal rows and diagonal rows would be numbered. Here are some examples of how we can represent terms as t and r. T 4, 2 is equal to 6. T 7, 6 is equal to 7, and T 9, 3 is equal to 84. Using Pascal's triangle for binomial expansion. Pascal's triangle can be used to solve binomials raised to any power, makes it easier and simpler to expand bigger exponents. Pascal's triangle expands binomials in the form a plus b to the power of n. In this case, n is equal to the row number in Pascal's triangle. The binomial theorem means we can use the coefficient from the specified row in Pascal's triangle, in this case it's 4, to find the expanded binomial with a few other steps. So the coefficients would be 1, 4, 6, 4, 1. In terms of the variables and their exponents, a starts with the highest exponent, being n, and b starts with 0, making it equal to 1. Each following term, you subtract 1 from a's exponent and add it to b's. b is stealing an exponent from a one at a time. In terms of the sign of each term, when there is a plus sign in the middle of the terms in the binomial, all the terms in the expansion are positive. When there is a minus sign in the middle of the binomial, the first term in the expansion is positive, and the rest of them will alternate. This is the final answer. Now we're going to add the variables and their corresponding exponents. The first term is going to be a cubed to the power of 4 and negative 3b squared to the power of 0. Now you just add the following variables and their corresponding exponents. Now, using your knowledge of exponent laws, you can simplify some of the terms inside of the expansion. Next, you simply solve each term using your knowledge of bedmass. Finally, you add the corresponding signs to each term. Since this binomial has a minus sign in it, the first term is positive and the following terms are all going to be alternating. You now know how to construct Pascal's triangle, how to name terms in Pascal's triangle, and use Pascal's triangle for binomial expansion. Thank you for listening.
Created using Powtoon.